Welcome! This lesson is on the concept of an electric charge and an electric field, which is a subtopic of electric fields and charges in Unit 18, Electric Fields. By the end of this lesson, you should be able to understand that an electric field is an example of a field of force. Before learning this lesson, some concepts we've learned in IGCSE are required to know. There are two different and opposite types of electric charge. These are called positive charge and negative charge. Like charges repel each other. For example, two positive or two negative charges will repel each other. The unlike charges attract, a positive charge and a negative charge will attract each other. The closer the charges, the greater the force between them. Where does electric charge come from? Everything is made of tiny particles called atoms. These have electric charges inside them. An atom consists of a nucleus and electrons, which is much lighter orbiting the nucleus. The nucleus is made up of protons and neutrons. Electrons have a negative charge. Protons have an equal positive charge. Neutrons have no charge. The SI unit of charge is the coulomb. Electron carries a negative charge of 1.6 times 10 to the power of minus 19 coulomb. A proton has the same size of charge as an electron, but is positive. So a proton carries a positive charge of 1.6 times 10 to the power of minus 19 coulomb. The magnitude of charge carried by an electron or proton is called the fundamental unit of charge. It is also called the elementary charge. Electrons are responsible for charging in most situations. An uncharged atom contains equal numbers of protons and electrons. Add one or more electrons to an uncharged atom, and it becomes negatively charged. Remove one or more electrons from an uncharged atom, it becomes positively charged. The value of a charge is only found in integral multiples of the positive or negative elementary charge. For example, the helium-4 nucleus, it's also called alpha particle, consists of two protons. A proton carries a positive elementary charge, E. So, the charge of the helium-4 nucleus Q is positive 2e. The elementary charge has a value of 1.6 times 10 to the power of negative 19 coulomb. Substituting the value of the elementary charge, we get the charge of the helium-4 nucleus is positive 3.2 times 10 to the power of minus 19 coulomb. An electric field is a region of space, such that, when a charge is placed at a point in the region, it would experience an electric force acting on it. A point charge, positive Q, produces an electric field all around it. This point charge is the source of the electric field, we call it the source charge. A charge can be considered a point charge if its size is very small as compared to the distance from which it is viewed. A small positive charge, small q, is placed as a test charge near the source charge. A test charge is a small amount of charge for the purpose of sensing and measuring the electric force. It is kept small to avoid disturbing the charge distributions which are responsible for the field. The test charge is standardized to be positive. This standardization is important because the sign will determine the direction of the electric force experienced by the test charge and hence the direction of the defined field. If the test charge is free to move, it will follow a path away from the source charge. The path a free positive test charge follows in an electric field is called a line of force or a field line. Electric field lines or lines of force are imaginary and are used to help us visualize electric fields. The direction of an electric field line is the direction a positive test charge would move along. So, the electric field lines radiate away from a positive point charge and radiate towards a negative point charge. A negative charge feels a force in the direction opposite to the electric field. Let's try some examples. Please pause the video to try the question. In this question, it's given that a negatively charged test charge is placed at point P, and the negative test charge experiences a force of repulsion from the charge x that is radially away from the charge x. Like charges repel, so the charge x is negative and produces an electric field radiating toward it. Obviously, option C is correct. We have come to the end of this lesson.